So there's just one more thing on this inequality stuff we got to remember, and so far we're doing pretty good. If you can solve equations, you're in good shape. But there's just one thing that we have not seen. That is if we have negative coefficients for the x. So when we solve these, and if that happens, there's just one thing we have to remember when solving at these. So let's compare any two numbers that we want, such as, I don't know, 24 and 7. Okay? Pretty common numbers. Pretty easy to compare these two. Well, which of these is bigger?
24.
24, so the shalligat here would be eating the 24. The problem is remember, if we do something to one side of an inequality or an equation, we got to do it to the other side as well. Well, let's say that we multiplied both sides right here by -1. Okay. Well, then these two give me -24, and these two give me -7. Now, which is bigger? -7. See how it flipped the inequality right there? By multiplying by negative on both sides, it flips the inequality. That's really the only thing we're going to add to this lesson, other than doing word problems as well. So you need to remember that when you either multiply or divide both sides by negative, it will flip the inequality. Always. Alright, so let's answer these questions. If you multiply both sides of an inequality by the same positive number, do you expect the inequality to remain true? The answer is yes. Yes. Because they are still positive. Well, what about this next part right here? If you multiply both sides of an inequality by the same negative number, do you expect the inequality to remain true? No, the answer to that one would be no. No, because the bigger positive will become a bigger negative. Bam. There it is. So again, that means that you have to flip the inequality if we multiply both sides of the inequality by the same negative. Or divide. Alright, solve the inequality. X over -2 is less than 2. Explain your procedure. Write and graph the solution. So really all we're going to do is show our work on these. So we got x over -2 less than 2. What would we do to solve at these? Yeah. Correct. If we multiply both sides by -2, -2 divided by -2 is 1. So we get 1x, which is what we do want. And 2 times -2 is -4. But since we multiplied by the negatives right here, it's going to flip the inequality. And this is our new inequality right here. 1x or x is greater than -4. So let's go to the graph then. We need to label some of these values. So let's say that this is -4 right here. And we have to be careful on these graphs because on the test you are going to have to label the graphs. So if that's -4, then this is -5. Because when we go farther to the left on the number line, the negatives get bigger. And then we get a -3 right here. So at -4, would we have an open or closed circle? Open. It's open because it's only greater than. And is this one eating the x?
Yes.
Yes, it is. So it goes to the right. Bam. There it is. Alright, we can play with this one a little bit. Between these two, do you guys want greater than or less than or equal to or what? Greater than. Okay, let's make it greater than. Do you want equal to as well? Yeah. Alright, equal to as well. Let's look at that. So let's solve this thing and then we'll graph it. What would we do to solve it these? Yeah.
Times both by -3.
Correct. Now if I multiply both sides by a negative, what does that do to the inequality? Oh, we got these negatives, so it's going to flip this to be less than or equals to.
So does it do anything to the equal part?
No. Because we can flip the equals part, but it's still equal. Alright, so we got -3 divided by -3, which is 1x. -9 times -3 is positive 27. There we go. Alright, so let's go ahead and graph these. We'll make our own number line, and that's okay. So starting at 27 right here. So 28 radical and 26. So just by chance, if they don't label them on the test, which they won't, then all we need to do is see the two numbers closest to these two, the value that you have. So one below and one above, like this. And at 27, what do we have, an open or closed circle? Closed, because it's equal to. Does it eat the x?
No.
Nope, so it goes to the left. Bam. So if we were to check, the line that we have there in green needs to tell us all the values that are correct. So going back to the inequality, the original, x over negative 3 is greater than or equal to negative 9. So we just need to choose a value on that green part that would give us a true statement. What value do you guys want to test? Yeah?
5.
That's a good idea. 5 would work. Now it's not on the number line, but farther to the left is 5. So let's go ahead and replace x radical with 5. Well, is 5 over negative 3 greater than or equal to negative 9? Yeah, I mean, if we did the decimal right there, you'd get negative 2.3 repeating, which is greater than negative 9. So that's true. And you'd be good to go. What about dividing by negative? What do you expect? Solve and graph the inequality. Explain your procedure. This will work the same way as it does with multiplication. So on this problem, what would we do to solve for x? Yeah.
Divide by -2.
Bam, we're going to divide both sides by negative 2, right? Now if we divide both sides by negative also, see we got this negative, well, we need to flip the inequality as well. So that leaves us with 1x is less than negative 3. And then on the number line, right, the negative 3 right in the middle, what's to the right of negative 3? Negative 2. To the left? Negative 4. There you go. Negative 3, open or closed? Going to the left. This one does not eat the x, so it goes to the left. Alright, finish this sentence. When you multiply or divide both sides of an inequality by the same number, you flip the inequality. Bam, there you go. Alright, let's solve the following problems by writing the inequality first, and then we will solve the inequality. So this first one, Kyle and Mika aren't very good at the trivia game. In the game, a wrong answer gives your team a negative 2/3 of a point. If at the end of the game, Kyle and Mika have never scored more than 8 points, negative 8 points, how many wrong answers do they usually give? Well, on this one, we should define our x variable. So we're going to say that x represents the number of questions. Because how many wrong answers? So the number of wrong answers is x. Well, then we can make the inequality. We can see that for every wrong answer, how much is it worth? Negative 2/3 points, right? Now, in comparison, we're comparing this to negative 8 total points. Now, since negative 8 is the most, they've never scored more than 8 points, right? So that's the most they've ever scored. Would the inequality be eating the negative 8 or the negative 2/3 x? Yeah? Maybe. Maybe. Well, here's the thing is if negative 8 is the most, okay, that means that the number of points they scored has to be less than that negative 8, right? So we'd have to have a less than there. But the question is as well is could they have scored negative 8 before as well? Well, yeah, they just never scored more than that, so it's going to be equal to that. So this is our inequality radical. Now it does ask for the solution. So what would we do to solve these? Well, yeah, we can divide both sides by negative 2/3. But we did divide both sides by negative. So this is going to flip the inequality, be greater than or equal to, and that's a 1x. And then we got negative 8 divided by negative 2/3, which really would be multiplying by negative 3/2. And that's something we can plug into the calculator as 12. So the solution is 12, but we really should write that in some kind of words for these. So let's go ahead and do that. They have gotten 12 or more answers incorrect. And of course there's many different ways to say that. You could say at most they've gotten 12. At most they've gotten 12. No, that wouldn't work. They've always gotten at least 12 incorrect. That would also work. There we go. Alright, so we have the inequality and the solution and the words. You have $10 to spend at the high school carnival. If each game costs 25 cents, how many games can you play? Okay, that's good. Inequality. Let's set up the inequality first. We can see that we have this $10 that we can spend right there. Well, each game, which is going to be X, that's the number of games played. And we wanted to find the cost for those games. Well, we can see that it's 25 cents every game. So we got 25 cents times the number of games played will tell us the cost for playing games. But the question is you only have $10. So will this be eating the 10 or the 25 cents X?
This one, the 10.
Well, since 10 is the most you can spend, that means it has to be bigger than the other stuff. Now, if you wanted to, you could spend all $10, which means it could be equal to as well. So this is the inequality, and to solve with these, we'll divide both sides by 0.25. Now, did we divide in this case both sides by negative? No, we didn't. We divided both sides by a positive 0.25, which means it's going to stay greater than or equal to. And 10 divided by 0.25 is 40. So we got 1x and 40. 40 is greater than or equal to 1x. So what we need now is the wording for these. And we could say at most you can play 40 games with your $10. Bam. So we will fill in the inequalities on some of these, but we're just going to solve them and graph them. They're not word problems, so we don't need to express the answer in words, which is fine, but we will graph them. All right, what do we do to solve this one? Well, we want 1t on this, right? So we'll make this divide by negative 5. Because negative 5 divided by negative 5 is 1, so we got 1t. That's good. However, we did divide both sides by this negative, so we're going to flip the inequality. And negative 25 divided by negative 5 gives us 5. So 1t, we'll just make it t, is less than or equal to 5. Now we can graph. They did give us a graph, but it's actually easier to graph like this. We got 5, 4, and 6. So at 5, open or close circle? Yeah, this one's closed because it's equal to. Is it eating the t? Nope, so it goes to the left. Alright, 12, this one is a little bit different than what we may be used to seeing. So to solve this one, I would say let's multiply both sides by 3. Now, we are multiplying by positive here, so we get kind of used to just switching the sign no matter what. No, we're not going to switch the sign. The 3 that we multiplied was positive. Now this 3 divided by that 3 does cancel that out. And we're left with negative 2y is less than negative 12. Now we will divide by a negative 2, which will flip the sign. So I got 1y is greater than 6. And this would be the inequality portion of these. But let's go ahead and put the graph on it here. Alright. So at 6, open or closed?
Open.
Open. Does it eat the y?
Yes.
Yes, so it goes to the right. Bam. Number 13, I would recommend on these that we would divide both sides by negative 1/2. Now again, we did divide by a negative, so it's going to flip the inequality. And negative 1/2 divided by negative 1/2 is 1, so we got 1p is less than negative 4 divided by 1/2, so we'll just make that negative 4 times negative 2 over 1, which really just comes out to be 8. And that's our inequality. But let's go ahead and put the graph on again. So I got 1, 2, 3, 7, 8, 9. So at 8, open or closed?
Open.
Does it eat the p?
Nope.
Nope, so it goes to the left. Alright. On this one, what do you guys think we would do on this one? There's a few things we could do, but there's one that's really quite useful. I'm sorry, let's put inequality between that. What do you guys want?
Less than.
Less than? Alright, we can just do less than. We can just do straight less than though. Right? Alright, so if I multiply both sides by negative 4, what happens is the negative 4 in the denominator will cancel out with that negative 4 that we multiplied it by. However, we did multiply it by a negative both sides. So we're going to have to flip the inequality. So we get y minus 3, and 5 times negative 4 is negative 20. So we do have to do one more step to solve this, right? Now, at this point, we are not multiplying or dividing anything by negatives, or just multiplying or dividing at all. So we're just adding the 3 to get the y by itself, right here. And that doesn't do anything to the inequalities, which we should have learned, and we should know from last time. So negative 20 plus 3 is negative 17. Very good. So there's the inequality. Alright, then we'll just use this down here as the number line. 1, 2, This will be negative 18, negative 17, negative 16. Alright, negative 17, open or closed?
Open.
Open, going to the right, very good, because it's eating the y. Alright, so the first thing we want to do, just like we would on an equation, alright, is we want to get this negative 3n, because that's what it is. We want to get it all by itself. So, we want this just to be a negative 3n. We don't want that negative 2 there, so what do we do to get rid of it? This one would have to add 2, right? Because that makes that a 0, just like it would in an equation. Then I've got negative 5 plus 2, which is negative 3. Now, we didn't multiply or divide anything, so we don't have to worry about flipping the inequality yet. But, at this point, we have a negative coefficient of n, so to make it a positive n, or 1n, we have to divide both sides by a negative 3. So that's negative 3 divided by negative 3 is 1, that's good. But we did multiply both sides by a negative, so we got to flip that inequality. And negative 3 divided by negative 3 again is 1. Bam. There's our inequality. Let's go ahead and make the graph over here. So I got 0, 1, and 2. So at 0, open or close? Closed it. Does it eat the n? Yes, so it goes to the right. Done. Alright, well, whatever. What do you guys want on this one? Less than? You want equals to? I heard yes or no, and I'm too lazy to draw it in there. So we'll make it less than. Alright, so on this one, we're going to multiply both sides by 2. Now, we did multiply both sides by a positive right here. So it's not going to flip the inequality, it's just going to give us negative 36 is less than, but that's still a negative x though, right? 2's cancel out. So how do I make that a positive x? Well, I would show the phantom 1, making that negative 1, and I would divide both sides by negative 1. Now I didn't divide both sides by negative, so I would have to flip the inequality. So yeah, that becomes a positive 1x now. Negative 36 divided by negative 1 is also positive 36. So this is the inequality. Let's go ahead and graph these. 1, 2, 3. 35, that's a 3. 36 and 37. What do we do? I'm sorry, is this open or closed?
It's open.
Opened it. Is it eating the x?
No, it's
Nope, so it goes to the left. Okay, so what are we going to do on this one? Yeah, we're going to distribute the negative 2. Now, does distribution change the inequality? No, because it's not happening to both sides of the inequality. So we got a negative 2x. Negative 2 times 4 is negative 8. And of course, this is still greater than or equal to 28. So to solve with these, we want to get that negative 2x by itself. Very good. Excellent. So that gives us negative 2x is greater than or equal to 36.
And then you divide by negative 2.
Correct. Now at this point,
And then you change the...
yes, we did divide both sides by negative, which is going to flip the inequality. So we got 1x now is less than or equal to negative 18.
Would it always be changing? Wait, why is it greater?
All right, here we go. Number line. Open or closed at negative 18?
Close.
Closed it.
To the left.
Does it eat the x?
No.
Nope, so it goes to the left. Excellent.
This is easy.
We already did the graphs, but this has all the work and stuff on it. So we didn't use their graphs just because I guess we didn't really need
You
to.
made her open.
Yeah, that's okay. Yeah, we made our own. So we ignored those. Follow the structure below to solve and graph each inequality. The first problem has been started for you, which was extremely kind. Andy has $550 in a savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of the summer. He withdraws $25 each week for food, clothes, and movie tickets, which are all categorically equivalent. How many weeks will his money last? Okay, well, the known information, we know he starts with $550. He's going to take out $25 every week, and he wants at least $200 at the end, right? And so if we said W is the number of weeks money can last, then Andy needs to be, the money Andy has needs to be more or bigger than or equal to the $200. So that's how we came up with this inequality here on the right account. So all we need to do is solve that inequality. That was extremely kind of them. So to solve it these, let's go ahead and get that negative 25W by itself. We'll subtract 550 from both sides.
Then you get negative.
Yeah, negative 25W is greater than or equal to negative 350, right? Yeah, right. Now, when we divide by this negative 25, it will give us some positive value right account. 25. But we did divide both sides by negative, so we're going to have to flip the inequality. W is less than or equals to 14. There we go. So just so we know in words, because we should know this in words.
Rough it or no?
Let's just write the answer in words, okay? So, he can take out $25 per week for 14 weeks.
How do we know that?
Let me take that back. It's not for 14 weeks. It's for up to 14 weeks. Because this is an inequality. So if you wanted to do it just for 12, you would still have his goal. That's much better. So this can bring up another question for us. Is in the 14 weeks, how much can he spend there? Thank you. Well, we figured that out, right? $350. and it'd still be good. So we did figure out the solution and what it means, but it does want us to graph this. So we got 14, right? So we got a 13, 14, and 15. Doesn't matter where I put that on the number line. At 14, open or close? That'd be closed, because it was also equal to. And is it eating the W? Nope, so it goes to the left. So again, this means that any value to the left there, in terms of weeks, would give us a true statement, or it would satisfy the problem. So if you wanted to go for 5 weeks, or only withdraw $25 for 5 weeks, he would have met his goal. On vacation, Caitlin wanted to have her hair braided in multiple braids to cover her head. The beautician charges a flat rate of $4 plus 75 cents per braid. She saved $29 to get braids. How many braids can she get? Okay. Well, this is the known information. There's a $4 fee. And then it's also 75 cents per braid. And then she has $29. So let's define our variable. We can use, say, X is the number of braids she can get. Well, what is the relationship? So the relationship is how many braids she can get with her $29 at 75 cents per braid and $4. So she can spend up to the $29. So that's going to help us with the inequality up in here. Let's go and write that in. So she has the $29. She's going to be charged, so that's how much she has. Let's look at spending. She's going to have to spend that $4 because that's how much she's going to be charged up front. But in addition to that, she's going to be charged the 75 cents every braid for however many braids she gets. Now in this case, the $29 is the maximum she can spend because that's all she has. So we need the amount she spends to be less than or equal to that. So it needs to eat the 29, however you write that. That gives us the inequality. Let's go and solve that. So for this inequality, we would need to subtract 4 from both sides. So I got 25 is greater than or equal to 0.75x. And then I would divide both sides by 0.75. So I see that x, we didn't do anything with negatives on that, so the inequality stays the same. That's what I got, 75 thirds. Let me make sure I did that right. No, it's 100 thirds. Take that back, not 75. It's 100 thirds, which comes out to about 33.3 repeating. Now here's the problem though, is if she asks her to braid a third, or 0.3 repeating braids, she'll probably tell her no, and that's all she can do. So what's the maximum number she can actually get braided? 33, because she doesn't have enough for 34. So it's got to be less than or equal to 33 in this case. So in context for this problem, we would say that she can get up to 33 braids for her $29. Now we just need to graph that. I don't really need more than just that part of the number line. So we'll say this is 32, 33, and 34. 33, open or closed? It'll be closed, because it's also equal to. So we close that up pretty good. Is it eating the x? Nope. So it has to go to the left. There we go. Maria is starting a small DVD business online. She makes $2.25 on each DVD she sells. To start her business, though, she had to invest $750. How many DVDs does she need to sell before she starts to make a profit? Okay. So here's what we got. It's she's going to make $202.25 per DVD. Now here's the thing is that she's invested or spent $750 and she wants to make a profit. So the variable, we'll say X again, is the number of DVDs sold. And what's the relationship? Well, she needs to make back the $750. Since this one is talking about profit, if she makes $750, that will only give her break even. It would not be considered profit. So she needs to make more than $750. So the inequality right here, we can just do this down here. The inequality is we got $750 that she needs to make. She only makes $2.25 for every DVD. So if we multiply that by the DVDs, we will have how much she makes off the DVDs. And this one has to be greater because that's how much she's making. More than she spent, okay? So this is how much she spent in comparison to how much she will make. We just make our own number line. Alright, so we'll divide both sides by 2.25, giving us the 1x that we want. Alright, so when we divide that in the calculator, we get 333.3 repeating, which is a fine answer, except for there's one problem. Can she sell a third of a DVD? Not if she wants to make any money off that thing. So she actually needs to sell how many? 334. Because if she only sells 333, then she hasn't met the equal part of that to break even. So she's going to have to sell more than that, meaning 334. So she will have to sell 334 or more to make a profit. Alright, well, now that we have that, let's go ahead and make our graph. I guess we have enough space to use that one. So 333, it's a big number, then 334, and then 335. 334, open or closed?
Oh, what? Open.
Now this is going to be open.
To the right.
It's actually going to be closed.
Right.
Okay, because we moved it up, right? So that ended up being 334. She could sell that much and have a profit, so it could have been equal to that, okay? Now this one is eating the X, so very good. It goes to the right. Bam. Alright, the community swimming pool charges a flat rate of $50 for a birthday party plus $250 for each person. Deborah can't spend more than $100. How many friends can she invite? So there's a couple things we need on these. And that is that we got some known information. Alright, so again, let's look at the known information. There's a $50 fee just for wanting to have the party there. They call it a flat rate, $50. But then in addition to that, it's going to cost us $2.50 for each person. And all we have on these is $100. So that is the known information. Let's define our variable x. Of course, you can use whatever letter you want, just not probably y or b. Well, I'm going to say that x, it should just represent whatever the question is we're trying to solve for. So that should be the number of friends. And of course, you guys are going to say, well, they don't have any friends, and then laugh. But that's real mean, okay? So be nice about it. What's the relationship? Well, we only have $100, so we have to spend something less than or equal to the $100. You could spend the $100 though, okay? So that leads us now to the inequality, which will be $100. That's as much as we have to spend. So that's how much we have. And how much we spend, it needs to be eating how much you have, or it can be equal to that, because you can't spend more than you have. Well, how much does we have? How much do we need to spend? It's going to be a $50 fee, but then in addition to that, we're going to add $2.50. And of course, $100 needs to be greater than that amount. So now we have an inequality which we can solve. And to solve this inequality, we would solve it just like we would an equation, subtract 50 from both sides. So minus 50. So it appears that on people alone, they have $50 to spend, and it's $2.50. I forgot the X on that, by the way, for every person. Well, to figure out how many people we can take in, we're going to divide this by $2.50. $2.50. And that gives us the 1x, which is what we want. And the number of peoples has to be less than or equal to 50 divided by 2.5 at 20.
20, yep.
20. Now this is the inequality that we solved, and of course if you set it up differently you may have gotten x less than or equal to 20, and that's okay as well. But we do need to describe the solution. We can take up to 20 peoples. Because if we take 20 peoples, we're good. If we take any less than that, we still have enough money to cover the charges. So that's the definition, or that's the defining the solution. Next up, we need to graph of these. So we got 19, 20, and 21. And based on our inequality at 20, open or close? Bless you. Open or closed? Very good. Closed. And is it eating the x? Nope. So it goes to the left. Bam. There it is. David owns a yellow cab. The company charges a flat rate of $2.50 for every cab ride plus 85 cents per mile. David figures he needs to average at least $12 for each cab ride to make a profit. At least how many miles must rides average to make a profit? Well, David figures he needs to average at least $12 for every cab ride. So let's look at some known information.
Is it 5 cents?
It's 85 cents per mile. So there's a flat rate in the cab, some kind of fee up in count, which is going to be $2.50. And then it will also cost 85 cents per mile. That's per mile. And we need each cab ride to be $12. So $12 per ride will give us some kind of profit. Alright, well, let's define our variable then. X, again, we want to know how many miles on average a person must ride. So X is the number of miles. Number of miles per ride. The inequality sign, we'll get into that. It depends on how we write the inequality. So let's go ahead and write the inequality now. So there's a couple things. We know how much is needed. And we're going to compare that with how much a ride will cost. And how much we need needs to be, well, we want the cost to be greater than or equal to what we need for profits. All right, well, how much does it cost? Well, the cost is going to be $2.50. But then in addition to that, we got to add another 85 cents. But that's per mile, so we got to multiply that by the number of miles. this must be greater than or equal to the need, which over here said was $12. So there's our inequalities. Very nice. These. So the first thing we need to do is get that 85-cent x by itself by subtracting 250 from both sides. So minus the 250 up and count. And we got 0.85x is greater than or equals to 9.5. And now, to solve with these, we'll divide both sides by 0.85, which we can do on a calculator to see that x is greater than or equals to. And here I've got 11.1 rounding 18. Now this was the number of miles every trip need to be. I suppose they could charge 0.18 miles, so we can keep it like this. But to describe this in voids, which we will do now, we'll say each cab ride must be at least 11.18 miles. Alright, now let's go ahead and graph these. So at 11.18, we need some graphage up in here. So this can be 11.17. This one can be 11.18. And this one could be 11.19. And at 11.18, we're going to have a closed cycle. I did round it, by the way. Closed cycle, because it's also equals, and it is eating the x, so it will go to the right. Jacques has a prepaid phone plan. He has $45 to spend, and each minute costs 39 cents. What is the most minutes he can purchase? Okay, well, let's look at the known information once again. So this is how much you have. You have $45. And each minute costs 39 cents. So 39 cents per minute. And that's it. What is the most minutes you can buy? There's no initial fee on this, which is very nice. And we can say that X will be the number of minutes he can purchase. Alright, so the inequality sign, we'll get into these. So we got how much he can spend as compared to how much he has. Compared to how much he has is $45. And how much it will cost. That sounds good. The cost is 39 cents for every minute. Now he has $45, so he could spend all of it if he wanted to, but he really needs that to be more than or equal to the 39 cents for every minute. So that gives us then, this one is extremely difficult to solve because of the decimal. So dividing both sides by 0.39er, that gives us 1x, which is good. That'd be 1 minute. And in comparison, we got 45 divided by 39 cents. I got 115.38. However, the problem is with this is that they don't usually sell minutes by the decimal. So what they will do is charge him 116 minutes. But can he purchase 116 minutes? No. Because he doesn't have enough money. So it looks like the most he can purchase is 115 minutes. So he could purchase 115 minutes equal to that or less with his $45. Nice job, Jacques. All right. Well, what does this mean in context? That is what we must write now. Jacques can purchase no more than 115 minutes You could say, if you wanted to, that the maximum number of minutes you can purchase is 115. That would be fine. But what we have there is going to work as well. Inequality, and we're going to use the one that we solved for. So at 115, so I've got 114, and on the test, by the way, you're going to have to make these graphs yourself. But we only need 3 values, even though like this one, it gave you more lines to use. I'm just going to put on there 114, 115, and 116, and then we'll graph right count. All right, so at 115, we got a closed cycle because it's equal to. And it is not eating the x, so it's going to have to go to the left, which should make sense. He needs to be purchasing 115 minutes or less than that, so it should be to the left. Harry, who is a wizard, wants to download some songs to his MP3 player. If he gets $20 gift card for his birthday, each song costs 90 cents, and at most, how many songs can he download? Well, again, we gotta look at the known information. What we know is that he have $20. It's in gift card form, but it's as good as cash. And each song, one song, equals 90 cents. Yep. And we want to know how many songs he can download. So X will be the number of songs that he can download. So the inequality will include how much he have compared to how much he will spend. And he can't spend more than he have, so the have has to be eaten by the shalligat. Of course, he could spend all of it if he wants to. Are you okay? All right. How much does he have? He got $20, and each song will be 90 cents. And we're going to multiply that by the number of songs he can download. Now, of course, that needs to be, the 20 needs to be greater than that value. So, right account, we'll just divide both sides by the 90 cents. And we see that the number of songs he can download should be about 22.2 repeating. So, could he buy 23 songs? No. As is correct, the maximum amount is going to be this 22, because as far as I know, and this hasn't happened yet, but I suppose someday you can make a brand new industry that does sell songs that come in the decimal values. Okay, just type in the decimal value of the song that you want, and then they will give it to you. Usually they call those samples, and they're free, but whatever. All right. So let's look at this. So we got 22 right here. Of course, we need 3 values on this, one to the left and one to the right. 22, this one can equal 22, so we'll make that a closed cycle at 22. This one is not eating the x, so it goes to the left. Bam, there's the fraction. That's not a fraction, that's the graph. That's better. Well, there is something we're missing, though. We need to describe the inequality in words. So, the person, I forget his name. Yeah, the wizard, that's right. The person can download 22 songs or less. There it is.